everybody. So today we have dividing a whole by a fraction. It says we can divide whole numbers by fractions using similar methods as the previous handout from yesterday. So here we're going to be looking at a bar model, and our first question here is 2 divided by 3/4. Well, what they're asking of us here is how many 3/4 are there in 2. So here our bar represents 1 and our second bar represents 2. So here's 4/4 here and 4/4 here. So there's my whole number 2. Now I went ahead and I shaded in some of these, and just follow me throughout this process. It's a little bit confusing. So basically they want you to count for every 3/4 is going to be 1. So here's 3/4 right here. So every time I have a fourth, so there's 1/4. If I keep counting, there's 2/4, and then there's 3/4. So that is going to be 1. That is a total of 1. That's a set of 3/4. And that could be the same as saying 1/3 3 times. So as you know, 1/3 plus 1/3 plus 1/3 is going to end up giving me 3/3, which is going to be 1, right? I know it's a little bit tricky. Right? So 3/3 is the same as saying 1. And I just want to show you this so that you recognize why the 1 is there. Okay? So that 1 is also equal to 3/3. Alright, so again, what I'm doing is seeing how many 3/4 there are in a whole number 2. Well, how many 3/4 are there? There's 1, 2, 3 here. There's 3 of the fourths. So that is a set of 1. 1, 2, 3/4. So now I have a set of 1. And a set of 1 here, think of it as a whole another number. So instead of having a bar that is there, you can think of it as now it is cut up. Now this is my whole 1/3, 1/3, and 1/3, giving me a whole 1. So then I can do the same thing down below, and just to show you that it's going to be cut up into thirds, I'm going to drag my pink box over to here. And show you that this is also going to be a set of thirds. Alright, so here's another set. So I have one set of thirds, I have another set of thirds, and then finally I have another set right here. And again, I'm going to need to make sure that these are cut up appropriately. Alrighty, so for my first bar that originally had a total of 4/4, I counted a fourth to 3/4, right? 1/4, 2/4, 3/4. Now I have a whole 1. Then I have another set right here. So again, I could count 1/4 that was there, 2/4 that was there, and 3/4 here. And just remember that there was another fourth there, but I'm only wanting a set of 3/4. So again, that's another third, another third, and another third. Alright, so now I've gotten one whole set, I have two whole sets, and now I don't have a full number here, so I have a fraction here. So I have an extra third and another extra third. My one's disappeared on me. But I think you get the point. I guess that's why. That's okay. But I think you get the point here. That these are thirds, and we're adding them together. Alright, I'm going to leave that there. Alright, so for the next problem, oh, finally the answer, right? So how many sets did I have? I had a set of 3/4 here. There was one set, two sets. So I had now a total of two wholes, which would be 1/3 plus 1/3 plus 1/3. And then I had an extra set down here that was 2/3. So my answer for that one is going to be 2 and 2/3. The whole number 2, it's a mixed number, 2 and 2/3. A little bit complicated, but if you just remember, you have to count sets of 3/4. So there was 3/4 there, and remember, I had a whole, it was cut into fourths originally. So once I got my first set of 3/4, I created a new fraction and a new bar. This is 3/3. The same thing on below, and then I had a little bit extra here from my boxes left over. So I should have 8 boxes total, right? I still do, but now I've broken the bars down into thirds. And I have some left over, so I have 2 and 3/3. The next problem is actually a little bit easier. So they have the whole number 4 here, so they represented your bars. Each one is worth 1, so I had 1, 2, 3, 4 bars. And then they were dividing each bar into half. Well, I went ahead and divided each bar into half. So they want to know how many halves there are in a whole number 4. Well, I can simply count how many halves there are. There was 1 here, 2, 3, 4, 5, 6, 7, and 8. Each part of this is a half. It's half of the whole number. So how many halves are there total in 4? You have 8 total. And you can think of it like this. If you had $4, how many sets of 50 cents would you have? Well, you'd have 50 cents. You'd have 8 sets of 50 cents. So your answer for this one is going to be 8, because there are 8 halves in the whole number 4. So down below, you can use the models from above that can help you out. All right, so you're going to need to represent a bar that is 3. So you're going to have 3 bars down here. And I'll try to help you out a little bit here. And then each of these bars are going to be broken down into sixths. So that means I'm going to need to break each of these bars into 6. And let's see if I can do that fairly quickly. Probably not, I'm going to be honest. Let's see. 1, 2, 3, 4, 5. Alright, now it might not be perfect, right? And I don't expect yours to be perfect, but I can tell you this, is that the more equal the spaces are, I think the better and more accurate your math is going to be. Okay? So I'm going to do my best to try to make these as equal as I can. Alright? So each bar is going to look like that. Now, I have represented here is 3 holes that I'm breaking up into sixths. But now I'm going to need a set of 5. So every time I get a set of 5, I'm going to count it as 1. Alright, and I'm going to use my my draw marker. I don't want to get crazy. Okay? So I have to shade, for every time I shade in a total of 5 units, that's going to be 1. So I'll tell you what, let's use a box. Let's do it. I'm going to use a small box. Alright, so I got 1 there, right? And I got to do this 5 times. So this would be, each bar is represented as 6, 6, but I only want 5, so I'm going to have a leftover. So now that I have all 5 shaded in, this is 5, 6, I have a set. So my first set here is 1. And I'm going to represent that 1 in each of the sets. So there's 1 set, right? And if I do that again, and I guess I'll use a different color. I guess this time I'm going to use maybe, let's see what kind of colors we have here. Let's use this turquoise here. That looks like a nice color. Alright, so here's going to be my second set. So 1, 2, 3, 4, 5. That was a set of 5, 6. So now I need another set of 5. So 1, 2, 3, 4, 5. Alright, so how many turquoise do I have now? I have 1, 2, 3, 4, 5. Perfect. That's going to represent 2. So now I have 2 sets of 5, 6. And I could keep going like that. Let's see if we can keep going. I'm going to choose a different color here. Let's choose this nice yellow. Two, 3, 4, 5. Alright, so now I've shaded in 1, 2, 3, 4, 5. It's going to give me another set of 5, 6. So that is my third set total. Alright. So now I have some leftovers here, but now you have to realize that you've created a whole new bar. So your bar kind of ends here. So now how many, this is a total of 1 here. And what is the red spaces? What is this whole thing broken up into? So what I'm asking myself is, how much is this bar right here? So I have this whole bar. This whole thing represents 1. Now, how many pieces are in this 1? 1, 2, 3, 4, 5. Well, if my pieces are broken down into 5, I know I have a denominator of 5. So all of these are actually fifths. So I'm going to, each one is worth 1/5. And the same is going to go for all of them. Now they're all been broken down into fifths. Originally they were broken down into sixths, but I've created a whole new number by shortening the bar by a sixth. So we have 5/6 here. It's 1 set, 2 sets, 3 sets. And my bars have been broken down into fifths, so now I have 1, 2, 3 fifths. So I have 3 sets of 5/6, and then left over from the third hole is 3 fifths. So there's a good example for you. So, sometimes drawing the bars, draw 4 bars and maybe use different colors or use different shades with your pencil, or any way that you can figure out how to mark the fractions down. So for this one, every 2 is what you're going to be marking down. So you're going to count 1, 2, and that's a set, and then another set of 2, and then another set of 2. So a little bit difficult to draw these models, in my opinion. I mean, especially with the keep, change, flip method. I mean, that's really how we divide fractions, but it just goes to show you how these whole numbers are being divided by these fractions. And what they're asking for really is, how many sets of 5/6 are there in 3? Well, we have 1 set here, and then another set and another set, so there's 3 total sets of 5/6, so that's why my whole number is 3. And then I have some left over, so I have 3 fifths. Alrighty, let's go on down to the next page. If you flip your page over, it says reviewing dividing fractions. So use the following steps to divide fractions. Number 1, change a mixed number to an improper fraction. You cannot divide mixed numbers. They need to be put into improper fractions. Then 2, rewrite the first fraction. 3, change the division to multiplication. 4, find the reciprocal of the second fraction. And 5, multiply. And 6, simplify. Look, keep, change, flip. Take a look at number 5. I keep the first fraction. I flip the operation from division to multiplication. I keep the first fraction. I change the operation from division to multiplication, and I flip the second fraction. So now I can multiply right across, and 6 times 4 is 24, and 1 times 3 is 3. Now, I'm actually okay with you keeping this as an improper fraction, okay? But if you needed to make this as a mixed number, you would just need to see how many times 24 divided by 3 is. Well, 24 divided by 3 is also the same as saying 8. So you could have had 24 thirds as your answer, or you could have 8 as your answer. Because this is an improper fraction, but when I make it a mixed number, I have to see how many times the denominator can go into the numerator. Well, if I add 3 8 times, or 3 times 8 would give me 24. 24 divided by 3 gives me 8. So you're going to go ahead and do number 6 on your own, very similar to number 5. And then on the bottom, I changed it up a little bit because it wanted you to use dice and the directions were a little confusing, but it just says, solve the following problems below. So here are your numbers. You got 12 problems on the bottom, and you're going to write your answers where it says solution. So the reciprocal of 6/9 is going to be 9/6. Okay. And you can use any method that you would like. If you wanted to keep, change, flip here, you could. Okay. And if you got to do a mixed number like this one, you got to change it to an improper fraction. So you could have 3 times 3 plus 1 is 10, right? So you'd have 10 over 3 here. You might be asking yourself, wait, how did Mr. Hart get 10 over 3? Well, it's pretty simple. If you go back to the previous videos, I do show you how to change a mixed number to an improper fraction. Right? So we multiply the denominator by the whole number. That's 9. 3 times 3 is 9, plus 1 is 10. Now I can take the reciprocal here of 10/3, so that I have my new reciprocal is going to be 3/10. Alright guys, I think we should definitely focus on the bottom here. I know that the top is a little bit confusing with all the models, alright, and it can be very confusing. Modeling fractions with division, modeling division of fractions is extremely difficult. I'm going to be honest, the bar models are not my favorite. I prefer these area models up here. If I can find them, I love the area models. I think that's the best way to do it if you want to refer back to how to figure out modeling division with fractions, okay? Alright guys, that's going to do it. Alright, so make sure to complete your handout here, dividing a whole by a fraction, and do problems 2 through 12 on the bottom. And everybody have a great day and stay safe.